Okay, so we're going to just move on here. We're going to look at the second question in our data transfer instruction MIPS review sheet. Okay, so this one is going over swapping two array locations, and this really builds off of the first problem that we did in the previous video. It's going to assume that you've already loaded an array in memory with 10 numbers. Okay. So let's just assume, for example, that if we had an array that had 10 numbers and that they were stored sequentially, such that we had an array that looked like something like this. We had, say, actually I'll stay consistent with what we did over here, so we'll call this 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and we're going to ask the user to enter two array locations, all right, whatever they want to enter, okay. And this output example, they enter 2 and 4. What that would do is if we're starting at index 0, okay, is it would go to array index 2 and array index 4 and swap the values, okay. So here, if we had, so if we had index 2 and index 4 and we swap the values, we would put value 5 here and value 3 here, which is exactly what we see in our output in this kind of example printout. Okay, so that's the goal, right? That's the goal that we're trying to achieve. And this, we don't, the sample code here we pretty much I've already looked at, right? For just really showing kind of printing a string. We did something similar in the review for the first question, so I don't think there's really need to go over that part again. So let's take a look at the solution here. Okay, so the solution. So we look at part 2, and the first thing we need to do is we actually need to go and basically ask the user to enter the information, right? So we're going to say if we want to prompt them with a string that says, hey, enter array index, we can go ahead and do this. So this system call here, system call 4, that one, if we kind of look back at our reference sheet, system call 4 is the one that's used for printing a string. Okay, so for printing a string, and that string, I called it index string here. If we go all the way up to the data section, we can see that index string is listed and defined with this data, enter array index. Okay. So nothing really special about that. I think that was really clear from the kind of the first walkthrough what that's doing. Really what we're doing here is this first part is we're displaying enter array index, and then this system call here, system call code 5, is getting a number from the user, and it's the end result of the system call is the number that the user enters is in register V0. I'm going to go ahead and take that value of V0 and I'm going to stick it into register 5. Okay. We just need a place to store it. We're going to use V0 for other stuff. Right, V0 is the one that's necessary to use for system calls, so we just want to copy that data somewhere else so that we have it. All right, so here is where we really get to, when we look at these lines of code here, this is where we get to something that is a little bit more tricky and kind of gets at the heart of this problem. So let me just kind of define again that we've got our array, okay? And we have the global pointer GP is going to be pointing to the index 0 of the array. Okay, so on. And we have that set up, right? But what we really need to do is we need to be able to kind of consistently get the user, say the user enters, we'll do one more. Let's say the user enters 2, right? That they want to swap. Let's imagine that the user wants to swap this location here, okay, with this location here. Okay, so that's the goal. we need to, this location needs to be, we need to actually get that as an address in memory, right? We actually need to know, well, what address do we call that, right? It's array index 2, but that's not the address. We can't just refer to index 2 like you would in C or Java or a host of other languages. We actually need to give a specific address to get this to work, okay? And what that address, we can apply a little bit of math to get this to work, because really what that address is if you recall from the previous solutions, is that in a sense what array index 0, 4, 2, 3, 4, 5 is really 0, 4, 8, 12, 16, 20, etc. Right? So this would be like how this first block would be how you would refer to it in other languages. Like if you were doing like array sub 0, right? Or like array sub, let's call it sub I, right? If you were going to call it array sub I, you'd refer to it, right? That's how you would do it in languages you're already familiar with, that you've been using for a while, right? But we need something different. What we need is the addresses that are down here in this block, and we can actually apply a little bit of math to get that, right? What that math really is going to be the global pointer, our base address, right? Plus, right, whatever this index is, I times 4, right? And once again, the 4 comes from, because everything's stored as 4 bytes, right? Each address is a byte. We're storing 4 bytes at a time, okay, for each word. So if we do this math here, that's what that's really what this is doing down there. If we do that and we store the result, in this case we're storing it in T5. If we go ahead and we do that, we'll actually have that true address in memory that the person's referring to. So when the person, say, enters that they want to swap location 2, what they really mean is they want this address in memory to be the one that's being swapped with something else. Okay? That's the idea. If you understand that, the rest of it really kind of comes together. That's the hardest part of knowing how to solve this part of the problem. If you know that, part of this kind of repeats. Okay, so we look, this is the same thing it says before. It says, say, enter array index again. We're going to get the second one that you want to swap, and we're going to stick that in T6. Okay, so that would be imagining that this is the other one that they want to swap. So imagine they entered 5. Okay, and then we apply the same math here, and we're just storing it into T6, such that the end result is we have this T5 points to this address, and then T6 is going to point to that address, okay, which is global pointer plus the array index times 4 for 4 bytes. Okay. Then we actually perform the swap. Okay, so this actually does the swap operation. We do that by first taking the values of each memory location. So what this is really doing, let me write this to kind of our array again. Okay, remember we're swapping, let's imagine we're swapping this location and this location, okay? And what we want to do, right, so we know that we know that that T5 points here and T6 points there, okay? We want to swap those. What we're really doing is we're going to take whatever the value is in each spot. So let's imagine that the value here, let's imagine that T, it kind of, we'll call it, let's imagine that's storing, let's call it value, yeah, we'll call it 3, and this if it had 6, just making up numbers that were currently stored there. what this is going to do is it's going to take that value 3 that's currently stored in memory there. It's going to take that value, it's going to store it into T7, okay? And then the same thing here, T6, we're going to take the value that's stored in memory there, we're going to stick it into T8, right? And then we're going to take those values of T7 and T8, right, and we're going to write them to the opposite locations. Okay, we're going to write those to the opposite locations such that this is going to have value 6 and this is going to have value 3. Right, that's the idea. So this here is what actually performs the swap operation. Okay, it's similar to how you would be using temporaries to store to swap variables in other languages. We just kind of get the temporaries by default for the fact that we have to be loading things from between registers in memory. Okay, so that really completes question 2, right? If we run that, we can see it kind of in action. We go ahead and run this program. I'm just going to write everything sequentially. Okay. Which ones do I want to swap? Let's say I want to do 2 and 5, and that we could see that 2 and 5 were swapped. Okay. Numbers are slightly different than what I kind of wrote on the screen just because I was moving different things and writing different numbers than I did here in this live example. But you can see that 2 and 5, those indexes are now swapped, and we get the rest of the array printed out. Okay, so that's the walkthrough for question 2. I encourage you, if anything's confusing on that, I encourage you to go back through the video, listen to it again, ask me questions, come to office hours, post on Piazza. Please don't let anything be confusing, remain confusing, seek help, get the answers, because you don't want to have a gap in your knowledge moving forward. But thanks for listening, and please stay tuned for the last video in this sequence where we'll talk about the question 3, finding the minimum value in an array in memory. All right, thanks for watching.